Hello guys, welcome back. So in this video we are going to see the maximum value of sum by placing the three rocks, right? Rooks. So as you can see here, we have given the statement that we have a 2D array that is what chessboard, and in the chessboard I and j is the cell of value, right? And we have given the rooks in the same row, and or you can say column, attack each other. Same row and or same column, right, can attack each other, and we need to place three rooks on the chessboard such that the rooks do not attack each other. Means it will attack only if the rooks in the same row or in the column, otherwise it will not attack. Okay, then we have to return the maximum sum of the cell value on which the rooks are placed. Okay, so this is you can say hard question, as you can see here, right? This is a hard question, and it will be difficult to implement for you, but no need to demotivate it. You can implement as much as intermediate level question, easy question, so you will get the idea, and one day you will be able to develop your sense, your programming skill to implement the question like this. Okay, so this is a you can say hard question, and let's understand what you can do. You can pause this video in middle when you understand, then you can start implementing again. Okay, so let's continue. So we have given a chessboard like this. Let me scroll a little bit. As you can see here, so we have a given chessboard like this, and we have to find the answer, right? So as you can see in the explanation, we can place the element at 0 2 here, then we have 1 3 here and 2 1 here, right? And then if you see, the sum will become what? 1 plus 1 plus 2, right? And the you can say the value, right, at 0 2 the value was what? 1 here, right? Then value at this position was 1, but the value at this position was 2, right? As you can hear, right? You can see here. Okay, and then if you do the sum, you will get the 4 as its value, right? I hope you understand this video, right? So all the cell value we have to do summarize this value, and then we will get our value. Okay, so what is the intuition of this statement, right? So a problem statement, you can say, right? So we have given this statement, we have given a 2D array, and as a chess, you can say chessboard, and we have to place three rooks that it should not attack in the same column and same rows, right? So the problem you can say says or evolves around placing three rooks on the chessboard and such that they do not attack each other. So no two rooks share the same row or column, and the sum of the values of the cells they occupied is maximized, right? So if you understand about the ideas, right, the main ideas are like we have to select the top three values from the rows or columns. So the program first will decide whether to proceed or process by row or columns based on the smaller dimensions, and this minimizes the number of iteration. Means first we will decide, our program will decide, right? We will go by row or columns, then we'll decide the smaller dimensions. So this minimizes the number of iterations. Okay, then what we can do, we will go for each row or column, you can say the three highest value we will identify, and will store the these values along with the respective indices, you can say. So this will ensure that the most promising cells are considered for the placing the rooks. So this is the first thing that we will do, like we will select the top three values from row or columns, and that will see how we are going to do, right? Then what we can do, we will place the optimal values, you can say placement we will do. How we are going to find the optimal placement? So the first algorithm we will apply, right? And this is the actually we can say finding the way as a combinations, you can say we will try to find the combinations of these top three values, you can say, and we'll consider all the possible placement of the rooks. right? So actually you can say a way of making a combinations things we have. So the algorithm that we are going to do, we will iterate over all the combination of these top three values, and we'll consider all the possible placement of the rooks. So it will check that no two rooks are placed in the same row or columns by maintaining the skip indices, and will ensure that each subsequent rooks place avoid these indices. So the sum of the value for each value combination is calculated, and the number of sum is trackled, you can say. Okay, so why this approach we are going to use? Because we have to select only the top three values from the each row, and the algorithm that we will reduce the problem size. Now you can say we will focus only on the most promising cell instead of considering every possible values on the board. So we'll use the skip indices, and that will ensure that the placement of the rooks are non-conflicting. And so let's understand that how we are going to do non-attacking conditions also. Okay, so as you can see, we have taken we have given a you can say, so give me 1 second, let me increase the size little bit. Okay, so as you can see, we have given the class name and the function name, where we have the board, right? In this in this code, what we have to do, we will go with finding the row and columns, right, from the chessboard. So we have to find the row and column. We'll take it as a final, and then we'll create a options, right? So we will list that we will list out the you can say top three values from each row or column, you can say. And to do that, we have to create a list of integers, right? And we'll create a tree set. For the tree set, we will customize as one class will create. We are creating a custom class, and so the custom tree set is to keep track of top three values that is stored in the descending order. So how we are going to implement the top three? Let's see. So as you can see, we have created a class top three, right? You can create a separate in if you are using the Eclipse. So we can take a top three. We will extend the tree set because we are customizing the tree set, and we want to store up to three best elements in the from the given array, you can say, or after the sorting elements, right? So if we have we will create a, you can say, we are creating a constructor, and constructor will implement it in such a way that it will automatically do sorting. And to do that, what we have to do, we have to implement a comparator, right? And comparator will check its two values and it will sort it out. So for that, we will find the difference a minus b, we can say, and then all the differences will, if we have the, we will return that difference, and based on the difference it will store in the descending order like this. If you want to do ascending order, you have to write a here and b here. Okay, like this we can do. I think you are already, if you're Java programmer, you are already aware with this, right? So the comparator is, we are overriding the value, right? Two integer will pass, and the two integer will check internally in the array, and it will automatically sort. So if you are having a and b, we are passing, and we want to compare b and a, means we are, what we are doing, we are descending. If we are ascending, a and b we have to pass here. Here will be a, here will be b. Then to store the element, similarly we have to override the value. We'll pass the element, we'll add on to the super, and we'll check the size is greater than 3. We'll start polling out, and we'll return the element. Okay, so successfully you will have element added into the you can say your tree set. Okay, now if you'll talk about the things that we have gone through. So first, row and column, then options, and the top 3 will get from the top 3 classes that we have to customize the you can say tree set. Now we have to find if the row is less than equal to columns, right? Means we want to decide like are we going to iterate about the row or columns, right, that we talk about, right? And then we will find the smaller dimensions, right, so that it will become little easy for us to iterate. Okay, so if rows are less than columns, right, so we will loop through each row, otherwise we will loop through the column one. So this is the condition that will decide either we'll go with the row or columns, like that. Okay, but you have to do the same thing. Now if you'll go with all the rows, right, so first we will iterate through the rows, then through the columns, and we'll keep adding on top t3 that we have customized the, you can say, top 3 tree set. So we'll keep adding each new element onto this the t3, right? Then we will add we'll extract the top 3 from the you can say tree set, and we'll add onto the options list. How will go, how we are going to do? Options dot add, and then list of, we'll use the first, we will do poll first, and poll first. You will get the list of these elements, and will option will be stored here. So we are extracting the top 3 elements from their indices, you can say, and we are keep adding onto the option list, right? Similarly, if the row is not less than equal to the column, means we will go through the columns. We will not go through the rows, we will go through the columns. In that case, we'll proceed with all the columns, then all the rows, inner loops, right, because do, and then we will add all the you can say cell value onto the custom tree set, right? And then we will extract, similarly we will extract the all these top 3 values and their indices from the custom tree set, and will put onto the option list. Now if you'll talk about the initialization things, right, what are the things that are required here? So we will initialize the maximum sum we have to find from the values, right? So we will have our max, then we'll have our size, option dot size will do list, and we will iterate through the top 3, and to get the value we'll get best, then we'll get the skip index and the v, right? So the best is we will get the best value from the current row and column, because entire, if you have observed let me give me 1 second. If you have observed here, right, here, so we have to find the best one from here, from best one, right? Because which one is the best one that we have to find, so that we will get the best one, means we will get the best value from the current row and columns, then we'll get the skip index will do, and we'll get the top value, and similarly we'll get the value from the this one, you can say best at 1, we'll get the long one. And similarly we'll find we have iterate through all the row and columns, and we'll get we will pick the top element, and will update our best 2 we will find, and similarly we'll find best to A, best to B, and then we will combine the values, right? Then similarly we will combine the values, and we'll find our the sum. How we are going to find the sum? v1 v2, and this value will calculate the sum of the 3 best values, and then we'll have our sum max is equal to sum now, right? And then we'll return the max, right? So this is the simple program of the hard program, you can say, and we'll store the elements, right? We'll take a utility methods to find the not matching index. We'll check the indices is not matching, will return null. Otherwise, if we have the data, we'll return the indices. Okay, I will put this code into the comment box. Okay, please go through the comment, and please get the code. Thank you for watching this video.